Alright, so the last video I said I would do those last two problems with you in the future. Well, that future has come. So what I'm going to have you do is go ahead, get out that packet and turn to those two problems. Okay, so here we have two examples. I'm going to go ahead and work them through with you. This is an example where we're going to have an extraneous solution. Remember that first part of that word, extra? There are going to be two answers, but we need to check both of them because one of them may not work. So the steps are the same as before. If we want to get our radical on one side, we've got that already there. Next step, we want to raise it to a power to get rid of that radical. So I'm going to raise both sides to the second power because it's a square root, so we square both sides. And on this side, we just get x. And over here, you know the most common mistake? Students will say x squared minus 4 or x squared plus 4. But that is not actually how we need to do this. That only works when there's a product where you distribute that power to each part. This is not a product. This is a difference. So we actually need to write it out 2 times. And I want you to go ahead and write parentheses and write it out 2 times. X minus 2, x minus 2. All right, so we're going to multiply those together. We can use distributive property, x here and there, and then here and there. So we get x squared minus 2x minus 2x, right, and plus 4 equals x. All right, so we want to combine our like terms. And we get that. Now, in all the problems leading up to these problems, we ended up here with a linear equation, and we could just solve for x. But in this case, we have a quadratic. So in order to solve a quadratic equation, we looked at all last unit was we have multiple options here. We could get one side equal to 0 and use the zero product property. So we could subtract x from both sides. We get x squared minus 5x, right? So we have 4x's minus, negative 4x's minus 1x. So we get negative 5x and plus 4. So we can use something called the zero product property, right? If we have a product of two things multiplied together and they need to equal 0, either this can equal 0 or that can equal 0. So I just want to factor this and say, okay, well, what multiplies to give me 4 that adds to give me negative 5? I know that x times x gives me x squared. And if I think about, okay, how do I get 4? 1 times 4 or 2 times 2? Which of those can add up to get me 5? Well, these guys, but I need a negative 5. So they both need to be negative. So they multiply to give me positive 4, they add to give me negative 5. So x minus 1 and x minus 4 would be my two factors. Now, the zero product property states that either this has to be 0 or that has to be 0 or they're both equal to 0. So I set each part equal to 0. X minus 1 equals 0 or x minus 4 equals 0. And then solve for x. X equals 1, x equals 4. And you would think that maybe we're done, but we're not, right? We need to check for that extraneous solution. So I'm going to plug 1 back in here everywhere that I see an x. These are two separate problems that I need to check. I'm not plugging this in for this x and that in for that. Don't do that. So if x was 1, plug in 1 for my x's. So I have 1 minus 2 equals the square root of 1. Square root of 1 is 1, and 1 minus 2 is negative 1. Are these equal? No, they're not. That is a false statement. So this is not one of my solutions. This is my extraneous solution. So let's check this one. 4 minus 2, right? Plugging in 4 everywhere I see an x in my original problem. 4 minus 2 equals the square root of 4. Square root of 4 is 2, and 4 minus 2 is 2. 2 equals 2. That's a true statement. So here we had a false statement, so it was extraneous, but here a true statement tells me that, yep, that is the solution. That is an answer, an x that makes that equation true. Okay, so our answer here, x equals 4. Same process here. We're going to square both sides, right? All right, and what do I need to put right here? that's where you're supposed to answer. Okay, so you're going to tell me, oh, write it out 2 times. Yeah, write it out 2 times. So I square root and I square the square root, so I get 2x plus 28. And then I want to write it out, x plus 2 times x plus 2. All right, so when I multiply these together, right, I get x squared. We have to make sure you do your inners and outers as well as your first and last, right, or you do distributed property. So x squared plus 2x gives me 4x and plus 4 equals 2x plus 28. So again, I've talked about this box. Like, this is like it's trapped underneath this radical, and you cannot touch anything in there until you deal with that square root, and you then this, see this 2x plus 28 just drops straight down, right? This key kind of unlocked this box. All right. So again, we want to get one side equal to 0, subtract 2x. So I subtract 2x here, 4x minus 2x, and then subtract 28. Subtract 28, and I get negative 24, right? X squared equals 0. All right, and then again, I'm going to factor, right? I want to use the zero product property. So it needs to be a product and it needs to be equal to 0. So what gives me 24 that adds to give me 2? I'm going to let you guys try and solve this. So hit pause for a second. You want to factor this out and then hit play, and then the answers will pop up. All right, so once we get here, we want to look at what factors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and we see, there's a difference of 2 here. We need the 4 to be negative, so you get there. You want to set each part equal to 0, add 4 to both sides, check both solutions, and this one is a correct solution, this one is extraneous. All right, let's try another one. All right. This is a doozy. Okay, go ahead and try this. This is not on your packet, so go ahead and write this down, maybe get some paper out. We are going to do same steps. So radical's already on one side. I'm going to square both sides, right? And what do I need to put right down here? That is correct. I need to write it out 2 times. All right, x minus 12, x minus 12. All right, and over here, this square root has this whole thing in it, so the square root and square cancel out, and I get 16x. On this side, when I FOIL those together, I get x squared minus 24x plus 144. All right, what would my next step be? Correct. Because it's quadratic, we need to get one side equal to 0. If you didn't say that, that's all right. Next time I ask you, the answer is get one side equal to 0. We want to subtract 16x from both sides. Here we get, we get equal to 0, 144. We add these up and we get negative 40x and x squared. All right, so again, we're going to factor. This one, you want to be careful, list out all the factors of 144. So we got 1 times 144. 2 times, let's half of that, so 72. No, those aren't going to add up to give me 40. How about, or subtract, 3 times, it's not divisible by 3. Okay, how about 4? 4 divide and I get 36. Aha! Now I need to get to negative 40. If I add these up, I get positive 40. So if I make both of them negative, they'll multiply to get positive, there's a positive 144, and they'll add to get negative 140. So I get x minus 4, x minus 36. Set them each equal to 0. X equals 4, and x equals 36. So I want you to pause for a second, check those answers, see which one is the extraneous one and which one works. All right, go ahead and hit pause. All right, and after you check, you should see that negative 8 does not equal 8, so 4 is not one of our solutions, but x equals 36 is a solution, right? I think there are 2 more problems. If you want to try these, come in tomorrow and we will get the answers to those 2 in class tomorrow. All right. Thank you for watching day 12.